Hello everyone and welcome back to another math video. In this video we are going to focus on finding equations of lines and then graphing them. So we're going to start out with how do we find slope? Slope is really a rate of change. We can think about it as the rise over the run. So it's going to be the difference in the y value. So it's going to be y2 minus y1 over x2 minus x1. And once we know slope and we know a point, then we can find the equation of a line. We're going to have y equals mx plus b, which is called slope-intercept form. M is the slope, so it's a number attached to x, and b is the y-intercept, so where it crosses the y-axis. And then we're also going to have point slope form. That's y minus y1 equals m times x minus x1. So what usually happens is we have 2 points, and we want to figure out the equation of the line between the 2 points. We're going to start by figuring out what the slope is. Once we know the slope, then we can jump to point slope form. We can plug in our number for slope. We can use either point to plug in for the x1 and y1. And then once we have this, we can solve it for the equation of the line in slope-intercept form. So let's look at a few examples. We want to find the slope of the line between the points 2, 3, and 5, 9. And then we're going to write the equation of the line. So I'm going to label these points. We're going to call that first point x1, y1, and that second one x2, y2. It does not matter if I say this is the first point and that's the second point or vice versa. I just have to keep the ones together and the twos together. So this, if I'm calling it 2, 3, the first point has to be x1, y1. That second point, 5, 9, has to say x2, y2. I cannot say this is x1 but y2 with the 5, 9. Okay, because it goes together, I got to identify both pieces as either first point or second point. So slope is y2 minus y1 over x2 minus x1. So we're going to have 9 minus 3. So that's my y2 and my y1 over 5 minus 2. So that's going to be 6 over 3, which is 2. So there's my slope. If my slope is positive, then that means this line is going to be increasing. So we'll go back to our notes section to say that. If the slope is positive, then the line is increasing. So it's rising from left to right. But if the slope is negative, then the line is decreasing. Which means that line, if I look at it from left to right, is falling. So in this case, positive, which means that we're increasing. So now we're going to find the equation of the line. Y minus y1 equals m times x minus x1. So I'm going to plug in what I know. So my y1 was 3, my x1 is 2. So I'm going to have y minus 3. My slope was 2, so that equals 2 times x minus 2. Now, I chose to use that 0.23. It doesn't matter if you use that point or the 0.59. Once we solve it for y, it's going to be the exact same line. So we have y minus 3 equals 2x minus 4. And then if I add 3 to both sides, I'm going to get y by itself. So y equals 2x minus 1. So my slope is 2. My equation is y equals 2x minus 1. So my slope is 2, my y-intercept is -1. Let's do another one. Let's say we want to find the equation of the line through the points -1, 4, and 3, -4. So this is my x1, y1, and my x2, y2. So slope is y2 minus y1 over x2 minus x1. So -4 minus 4 over 3 minus -1. -4 minus 4 is a -8. 3 minus -1 is a 4. So this one turns out to be a -2. Since my slope is negative, this line is following from left to right. So now let's find the equation of the line. So we have y minus y1, which I'm going to use 4, equals slope times x minus x1. So I have y minus 4 equals -2x minus 2. And if I add 4 to both sides, we're going to get y equals -2x plus 2. So my slope is -2. My equation of the line is -2x plus 2. So I want to show you what's happening graphically here. So I'm going to use Desmos. So I can just go to desmos.com, type in open graphing calculator, and I'm going to graph the points. So I have -1, 4, and then I have the point 3, -4, and I'm just typing them in using my keyboard on my computer. I found the equation of the line between those 2 points, and we said that's y equals -2x plus 2. You can see how that line goes through both of those points. So that's what we're finding here. We have 2 points somewhere on the Cartesian plane. We want to find the equation of the line that models that. And you can see if I read this left to right, you can see how that line is decreasing here. So you could always imagine yourself walking on it. If I'm walking on it, I would be walking downhill. That's how I know I'm decreasing. And that's because of that negative slope. So this one's going to do the same thing. You may want to pause the video, try it, come back, check your answer. This one's asking you to find the slope of the line through the points 0, -3, and 4, 5. So we're going to label them x1, y1, x2, y2. I'm using my slope equation. y2 is 5 minus y1, which is -3, over x2, which is 4, minus x1, which is 0. I'm going to get 8 over 4, which is equal to 2. And now I'm going to use my y minus y1 equals m times x minus x1. So we're going to have y minus -3 equals 2 times x minus 0. So we have y plus 3 equals 2 times x plus 0. And if I subtract 3 from both sides, I'm going to get y equals 2x minus 3. So my slope is 2. My equation is y equals 2x minus 3. So let's look at a different skill. Suppose we have the slope is 3 and the y-intercept is -2. Let's say they want us to write the equation of the line and then graph it. We could use slope-intercept form, y equals mx plus b. This one's nice because it already told us what m is and then what b is. So we're just going to plug that in for our m and our b. So it's going to be y equals 3x plus -2, or we could write that as 3x minus 2. So when we graph these, we're going to think about our slope, which is rise over run. Our slope is 3, so I'm going to think about that as a fraction 3 over 1, which means from the y-intercept, I'm going to graph the y-intercept first. And then from there, we're going to use the slope to plot another point. And then we're going to connect the dots. So my Cartesian plane, I'm going to rewrite that equation down here so I don't lose it. Y equals 3x minus 2. So here's my minus 2, and my slope is 3, which is 3 over 1. So from that minus 2, I'm going to move up 3, right 1. You have to do both movements to make the point, and then we're going to have the equation of the line. So we can connect those, and there's my linear function. That's how I would graph it. Let's look at the next one. We have a slope of negative 1/2 and a y-intercept of 4. So my equation would be y equals negative 1/2 x plus 4. And then we're going to graph the equation on the Cartesian plane. So we're going to have y equals, I'm going to write it on my next page. So slope is negative 1/2. Y-intercept is 4. So I'm going to start by plotting that y-intercept. Now, with negatives, I can either choose to put the negative on the top or on the bottom. I usually put it on the top, which means I would move up 1 and over 2. If I wanted to view it as 1 over negative 2, then I would move actually, let me go back here. I'm starting with the y-intercept of 4. My slope is negative 1 over 2, so it's rise over run, which means I would move down 1 and right 2. I said that incorrectly earlier. Negative 1 over 2 would be down 1 and right 2. Now, we could choose to view this as 1 over negative 2. So the positive 1 means from the y-intercept we would move up 1, and the negative 2 means I would move left 2. Either way, you're going to get points that's on that linear function, and all you do is you connect the dots. Well, what if we had the graph of the function, and we want to identify the slope and the y-intercept in the equation of the line? We could do that. So from here, notice the 2 red points here. We have a point over here at over 0 up 1, and then this other point is at 2, 5. Okay, using the graph, we could see how far we moved up from this point to get to the other point, from point 1 to get to point 2. So I'm going to move up 1, 2, 3, 4, and then over 2, 1, 2. So rise over run. I went up 4 and over 2, which means my slope is 2. Okay, even if I would have started at the rightmost point and gone over the other way to get to that second point, I would get the same answer. From here to 5 to get to 0, 1, I would have to move. Remember, it's rise over run. So my rise is actually falling. So it's down 4. And I would show that with a negative 4. And then I would move left 2, which would be a negative 2. But that still reduces to 2. So you get the same answer either way. And then my y-intercept is at 1. So my slope is a positive 2. My y-intercept is at 1. So y equals mx plus b would be y equals 2x plus 1. Let's look at this next one. So we can see that the graph is falling, which means we expect the slope to be negative. We're looking at rise over run. So I'm going to start at this first point, which I see is at 0, 3. That second point is down here at 3, negative 3. And we could find the points and use the equation to find the slope. That would be fine. You're going to get the same answer either way. So I'm going to do my rise over my run. So this one would be easy to count. So I'm going to go rise, which is really moving down. 1, 2, 3, 4, 5, 6. I move down 6, so negative 6. And I'm moving right 3. So my slope's going to be -2. My y-intercept is at 3. So my equation is y equals -2x plus 3. Now let's talk about horizontal and vertical lines. If we want to graph the line y equals 4, y equals 4 is a horizontal line. And for a horizontal line, the slope is always going to be 0. So to graph that, I would go up 4, make my point, and then I would just graph my line. This one actually graphed for us. Slope is going to be 0. If I'm looking at x equals -3, this is a vertical line. For a vertical line, the slope is undefined. Okay, vertical lines are going to go up and down. So if I'm looking at x equals -3, I'm going to start by plotting -3 right on that x-axis, and we would just draw that line vertically through that x-coordinate of -3. Slope is undefined. So let's look at another example. Let's say we want to graph the line y equals -2. Here's y equals -2. This is a horizontal line, which means the slope is going to be 0. Horizontal lines are going to look like this. They are parallel to the x-axis. The next one is the line x equals 5. X equals 5 is going to cross the x-axis at 5. So it's going to go up and down. This is a vertical line. It's going to be parallel to the y-axis. The slope is undefined. So let's say we have a graph of a horizontal or a vertical line, and we want to write what the equation is. So you have to identify which one it is. This one's horizontal, so I'm going to abbreviate that HOR. It's going through the y-axis at 3, so this is the equation y equals 3. Okay, let's look at the next one. So notice this graph is up and down, so this is a vertical line. So it means it's x equals something, and you see how it's going through that graph at x equals -5. So the equation of that would be x equals -5. So let's look at the next example. We have 10x plus 3y plus 4 equals 0. So this is in standard form. We want to write it in slope-intercept form, and that just means we want to solve it for y. So we have 10x plus 3y plus 4 is equal to 0. So I'm going to start by moving the x term and the 4 over. I'm going to move them both at the same time. Okay. So I'm going to have 3y on the left equals -10x minus 4. And then I'm going to divide every term by 3. So now I've got y by itself. Y equals -10 over 3x minus 4 over 3. So equation y equals -10 over 3x minus 4 over 3. So my slope is -10/3, and my y-intercept is -4/3. Remember, slope is a number in front of x when y is by itself. Next one, we have 4x minus 2y minus 8 is equal to 0. So again, I'm going to move the 4x. I'm going to move the 8. So I'm going to subtract 4x and add 8. So I have minus 2y equals minus 4x plus 8. And then we're going to divide everything by -2. Make sure you divide every term. So we have y equals 2x minus 4. So there's our slope-intercept form. Slope is 2, y-intercept is -4. You may want to take a minute and try the next one. We have 6 times x plus 2y minus 10 is equal to 0. So we're going to subtract 6x and add 10 to both sides. That leaves us with 2y on the left. Then we're going to divide everything by 2. So we're going to get y equals minus 3x plus 5. So my slope is -3. My y-intercept is 5. Now, what's nice about slope-intercept form is it makes it super easy to graph. So if we look at the next one, y equals 5/7 x plus 2. Slope is 5/7. Y-intercept is 2. So we're going to start by graphing that y-intercept, which is at 2. And then the 5/7 gives us the rise over the run. That tells us we're going to rise 5 and run 7. So we're going to go up 5, 1, 2, 3, 4, 5, over 7, 4, 5, 6, 7. And all you need is one other point, and then you can connect them to create your line. In this case, our slope is 5/7, and our y-intercept is 2.